Today we're going over how to create a linear equation from a graph and a table. First up, let's quickly review slope-intercept form. You should be well versed in slope-intercept form before you try to tackle this topic. Y equals mx plus b, of course, where m represents our slope, which is a direction. B represents our y-intercept, or where the line crosses the y-axis. And the x and y values represent every point on the line itself. If you know the slope and you know the y-intercept, it's extremely simple to write the equation of a line in slope-intercept form. If you know the slope is 3, for instance, and the y-intercept is -2, we simply substitute 3 in for m and -2 in for b, and we have the equation y equals 3x minus 2. That being said, that makes it easy to do if we have a graph, because in a graph it's very easy normally to find the y-intercept and the slope. For instance, here I have a graph and I can see right off that my y-intercept is at 2. Then, if I look at where the line actually crosses the grid itself, points that I can tell exactly where they belong, I can find the slope as well. I can see that from point to point, my graph goes up 1 unit and to the right 2 units. And with rise over run being the definition for slope, I know that the slope is positive 1/2. Then I can take the 1/2 and the 2 and write the equation of our line. That's all we have to do when we're writing the equation of a line from a graph. Find the y-intercept, find the slope, plug them in and you're done. Before we move on to tables, let's stop and think for just a minute. We've covered this topic before, but think about when exactly it is that you get a y-intercept. What's true of all points on the y-axis? Well, every point on the y-axis has an x value of 0. So we know that we have a y-intercept when our x value in any given point is 0. And on the other side, when exactly is it that we know we have an x-intercept? Well, on the x-axis, the y value is 0. Every point on the x-axis has a y value of 0. So if you ever see a point where the y value is 0, you know that it's an x-intercept. That's going to help us as we move on to tables. We want to write the equation of a line that's for the function that's represented in this table. And when you look at a table that represents a function, every row in that table represents a point on the graph. So for instance, we know that our graph contains the points -2, 9, -1, 6, 0, 3, and so on. If I want to find the x-intercept, I again look for a point where the y value is 0. And that happens down here on the next to last row. The point 1, 0 then is our x-intercept. So you can write the point 1, 0, or you can say the x-intercept is 1. The y-intercept is at a point where the x value is 0. So looking at our table, we can find the y-intercept right there at the point 0, 3. I can say the y-intercept is 0, 3, or I can say the y-intercept is 3. Looking for the rate of change, or slope, from a table requires taking a look at 2 different values. First of all, I'm going to look at the rate of change in moving from one x value to the next in my table. And as I progress down the x column, I can see that with every new row, I've added 1 to my x value. So the rate of change for my x values is 1. Moving down the y column, I can see that moving from one y to the next, I subtract 3 each time. From 9 to 6, from 6 to 3, from 3 to 0, and so on. Well, our slope, the definition of slope, rise over run, can also be written as change in y over change in x. Since our rates of change are constant in both our x column and our y column, I can confidently put in our rate of change for our y values and our x values in our table. That gives me negative 3 over 1, which of course reduces to negative 3. And that is our slope. Now we have a slope of negative 3 and a y-intercept at positive 3. I can substitute those values into our equation for m and b, and I get the equation y equals negative 3x plus 3. Let's look at another table. Can you find the x-intercept in this table where the y value is 0? Of course, at the point 1, 0, or we could simply say the x-intercept is 1. Can you find the y-intercept? That's at the point 0, negative 4, or we can simply say the y-intercept is at negative 4. To find the slope or rate of change, again we need to look at our two different rates of change. Once for the x column, and again for our y values. Seeing that these rates of change are consistent along the entire table definitely tells us that this is going to be a linear function. If those values were not the same, it would not be an equation where we can write the formula in slope-intercept form. So again, rate of change can be defined as change in y over change in x. This time I get 4 over 1, which reduces to 4, and our slope is 4. Taking the slope and the y-intercept, we can write the equation of this function in slope-intercept form. One more. In this table, can you find the x-intercept? This table is a little bit challenging because we don't actually see the zeros. All I know as far as the x-intercept is concerned, remember the x-intercept is where y is 0. I can't actually see the 0, but I know it's somewhere between these two values. 0 is between 3 and negative 1. So the only thing I know with any confidence about the x-intercept is it's going to be in between 1 and 3. I can't tell exactly where my x-intercept is. All I know, again, is that it's going to be between 1 and 3. The y-intercept, on the other hand, is where x is 0. And I'm going to show you a little bit of a trick to help you find the y-intercept. This trick would not have worked with our x-intercept, but it will for our y. The y-intercept is where x is 0. And I know that 0 is exactly halfway between negative 1 and positive 1. That means that our y-intercept is going to be exactly halfway between 7 and 3. And to find that midpoint, we take the average of the two values. So 7 plus 3 is 10. When I divide that by 2, I get 5. My y-intercept is going to be at the point 0, 5, or I can just say the y-intercept is at 5. The reason it wouldn't have worked for our x-intercept is because 0 is not exactly halfway between 3 and negative 1. So we can't do the same or use the same trick to find our x-intercept. Now on to rate of change. Again, we need to look for the change in our x values. This time we're adding 2 every time we go from x value to x value. And the rate of change for our y column, this time we're subtracting 4 as we move down our table. The rate of change then, change in y over change in x, is negative 4 over 2, which simplifies to negative 2. With our new slope and our new y-intercept, we can write the equation of the line. Okay, I think that's enough for writing linear functions from tables and graphs. I hope you have a great day, and of course, I'll see you next time.